Hello, everyone. Thanks for joining and welcome to another session of our Day One and Beyond series, where we take you through various topics and activities related to building out on Oracle Cloud. Our today's session is the Oracle Cloud Networking Quick Start, which will cover core OCI networking services, how to properly deploy, and best practices. Now then, I'd like to introduce Winnie Yang and Ernesto Torres as today's presenters. That being said, I'll hand it over to Winnie.
Thanks, Borna. Hi, everyone. Welcome to today's networking quick start. So I'll go ahead and display the agenda for what we'll cover. So we'll go over virtual cloud networks or VCNs, subnets, route tables, different gateways, peering, virtual cloud network security options, load balancing, and also different connectivity options with Fast Connect. So by the end of this presentation, we expect you to be able to understand the core networking services within OCI, be able to explain the differences between VCNs and subnets, be able to compare different networking gateways and know their use cases, and also provision and deploy networking resources within your tenancy. So first we'll cover kind of a quick introduction before we dive into the specific components. So this is a bird's eye view of the complete cloud infrastructure that Oracle operates and offers. So at the bottom, we have your different types of deployments. In the middle, in the gray area, these are our cloud services. And today we are focusing on networking. And then on top of all of that, you have your different applications that Oracle supports, whether that's Oracle apps, custom apps, or ISV apps. And then first up, we will go over virtual cloud networks. So these are software-defined networks that you set up within your OCI tenancy. They are set up in your data centers in OCI or regions. And within VCNs, we have something called subnets, and these are subdivisions of a specific VCN. So VCNs, as a reminder, they do reside within a single region, but they can cross multiple availability domains. If that's available, it's inside the region you've chosen. Within each VCN, there are different networking components, and they obviously affect the behavior of your network. And those components include route tables, security lists, different gateways, and so on. And we'll cover some of those today. And when you're creating these components, you're essentially establishing a relationship between that component and the VCN. So that means you do need to be allowed in an identity and access management policy to both create the component and manage the virtual cloud network itself. However, the ability to update that component, so maybe changing a route rule or updating a security list rule, and so on, these actions do not require permission to manage the VCN itself. So even though, taking that action or changing that component will directly affect the behavior of the network, um, you do not need permission to do so. So this is designed to give you flexibility in granting least privileges to your users and not required to grant excessive access to the VCN, just so the user can manage, other components of the network. So just be aware of this fact when, you give people the ability to update a particular type of component, you're also trusting them with controlling the network's behavior as well. All right, and then next we will talk about subnets. So as I mentioned earlier, subnets are subdivisions of your VCN. And you can have more than one subnet in a particular availability domain for a given VCN. Each subnet will have a continuous non-overlapping private RFC 1918 IP space, and these subnets can either be public or private subnets. So private subnets Your instances inside these private subnets will contain private IP addresses and assigned to VNICs. And then your public subnets contain both private and public IP addresses assigned to your VNICs. So historically, subnets in your VCN have been specific to a specific availability domain. So as you can see here, subnet A, B, and C, they are availability domain specific subnets. But more recently, OCI has introduced regional subnets. So that would be subnet D here as an example. Regional subnets span all availability domains inside the region. And you can choose whether the subnet will be regional or availability domain specific when you're creating the subnet. Aside from the removal of the availability domain restraint, regional subnets behave the same as availability domain specific subnets. And you can mix and match and have both um, regional subnets and availability subnets within your VCN. Next, we will cover VCN address space. So VCN covers one or more IPv4 CIDR blocks of your choice, and the VCN sizes available to you range from /16 to /30. The networking service reserves the first two IP addresses and the last one in each subnet's CIDR. You can enable IPv6 for your VCNs when you create them, or you can enable IPv6 on existing IPv4 only VCNs. And then next is a really important component. It is route tables.
Of course.
Okay, so going into route tables, so your VCN will use route tables to send traffic out of the VCN. So for example, if you're sending traffic to the internet, to your on-premises network, or to another VCN, and that connection is called peering VCNs. So these route tables contain rules inside them that look and act like traditional network route rules. Each rule will have a destination CIDR block that you need to specify, and then also the next target for any traffic that matches the CIDR. So we included a screenshot here to show you um, examples of route rules that you would need to create inside your route table in order to send your traffic out of your VCN. And then each subnet will have a single route table of your choice that will be associated with it. And then all of your VNICs in that specific subnet will need to follow the rules of that specific route table. All right, so next we will talk about gateways. So the first gateway that we'll talk about is Internet Gateway. The use case for using internet gateways is if you need to communicate to the internet. So the internet gateway provides a path for network traffic between your VCN and the internet. You can only have one internet gateway for a specific VCN. And then it's really important to set up a route rule for the gateway inside your route table after you set up your internet gateway so that you can enable the traffic flow. And then what's important to note about the internet gateway is that it enables traffic coming from both sides. So coming from the VCN to the internet and also internet to the VCN. Another way to communicate to the internet is using a NAT gateway. So a NAT gateway, it allows outbound connections to the internet, but blocks inbound connections that are initiated from the internet. So hosts, they can initiate outbound connections to the internet and receive responses, but they cannot receive inbound connections that are initiated from the internet. So it's a great way to keep things secure. And I would say a good use case for using NAT gateways is if you need to update or patch anything. And then our next use case is communicating to your on-premises network. So in order to do that, you'll need to use the Dynamic Routing Gateway, or DRG for short. So the DRG provides a path for private traffic between your VCN and destinations other than the internet. So on the on-premises network, destination is kind of just one way to use your DRG. But essentially, in addition to on-premises networks connection, DRGs can also be used to route traffic between VCNs, which we will cover in a future slide. But you can use different attachments, custom network topologies to set that up. And for this specific use case for on-premises network, you'll need to use either an IPsec VPN or Fast Connect to set that connection up. And VCNs and DRGs do have a one-to-one relationship. And then next we have communication to public OCI services. So for this use case, you'll need to use a gateway called service gateways. And service gateways let resources in your VCN access public OCI services such as object storage, and you don't need to use the internet or NAT gateway or traverse over the internet. So it keeps it secure and gives you a private connection. So any traffic from the VCN that is trying to head towards, any of the supported OCI public services, it will use the instance's private IP address for routing. It only travels over OCI network fabric and it never traverses over the internet. So one use case for using service gateways is if you need to back up your database system um, to object storage. So you would leverage the service gateway to establish the connection to object storage so the VCN can send traffic to object storage. Next, we will talk about how to communicate to other VCNs. We call this peering. So one way to peer is to locally peer. So that's the act of connecting two VCNs within the same region so that their resources can communicate using private IP addresses. So there's two ways to set up local peering. You can either use the local peering gateway. Let me see. Okay, yeah, you can use the local peering gateway. So you'll need to establish that in both VCNs. So in this case, VCN1 and VCN2. However, if you have something called an updated DRG, so it's basically just the most updated version of DRG, I think maybe like 2021 or 2022, then you would use the updated DRG to establish the local peering. And yeah, it's something you'll need to establish within your VCNs as well, and then go to your route table and establish that route rule. Another type of peering is remote VCN peering. So that is the act of connecting two VCNs in two different regions. As you can see here, we are doing a remote VCN peering on VCN1 and VCN3 located in different regions. So they're using their private IP addresses to communicate with each other. So for a remote peering, you'll definitely need an upgraded DRG. So you'll need to set that up on, again, both VCNs and then establish that connection and set up your route rule in your route table as well. Another thing about peering VCNs, you just want to make sure that you don't have overlapping CIDR blocks. So next we have a networking demo. So I want to go over kind of the basic networking components that I just talked about. So the VCN, subnets, and some of the different components. So we'll head over to okay, so I'm sharing my screen now. I'm in the OCI homepage. So we'll head over to the menu button on the left-hand side here, and then you can go ahead and click to networking, and then we'll get started in virtual cloud networks. So like many other OCI resources, virtual cloud networks do live in compartments. So you want to make sure that you've selected the correct compartment here. So for us, I'm going to go to the Vision Corp compartment. Vision Corp is a mock company that my coworkers and I have created specifically for demos and enablement purposes. So as you can see here, we have created two VCNs, but I want to show you how you can go through the creation process. So there's a couple ways to set up your VCNs. If you kind of just want like a bare bones VCN, then you can just directly click on the Create VCN button here. But there's also something called a VCN wizard where we create a VCN, but we also have some additional networking components for you to get started based on your use case. So I'm going to go through the VCN wizard really quick. So these are the two use cases that we have for you to choose from. It's either, you need internet connectivity or you need internet connectivity and connection to an on-premises network. So we'll go with the internet connectivity use case for today, and I'll walk you through the wizard steps. All right, so first you get an overview on what this includes. So you not only get the VCN, but you also get a public subnet, a private subnet, an internet gateway, NAT gateway, and a service gateway. So first off, give your VCN a name. So I'm just going to go with testing and then select the compartment you want this VCN to live in. Go ahead and configure the IPv4 CIDR block for your VCN. You can also enable IPv6 here by toggling it on. And these are the public and private subnets that will be created. So you can specify the CIDR block as well. And then you can go ahead and click next. And this is just a review page of what will be created after you click create. So you have your VCN, you have your subnets, private and public. You have your different gateways. So we have internet, NAT service, and then we also have some default security lists and route tables in order set up for you to if you want to use your VCN right away, you need to have these set up. So you can also take a look at the rules. Ernesto will kind of go into more detail for the security lists, but this is just a way for you to allow and not, what's the opposite of not allow certain traffic coming in based on the IP address to just keep your, tenancy secure. And then once that looks fine, you can go ahead and click create down here. So I'm going to cancel, but I will show you what a created VCN looks like. So I'm going to click into demo here. And then right off the bat, you can see the VCN information. You can see the different the different subnets. So for us, this one doesn't have any. And then if you had any gateways, it would be displayed here. So we have a NAT gateway, a service gateway, and then your route table will be here as well. So if I click into, let's just say this default one, and I click into route rules, I can see the route rules that have been created, but I can also add my own. So I can show you how to set that up. You can select a target type. So usually that'll be a specific gateway, or you can have it as a private IP. And then go ahead and input your destination CIDR block, and then select the target type. So for us, we do have to select the actual gateway as the target, and then a description for, what this rule is for. And then you can add your route rule to your route table. All right, so that pretty much concludes a quick kind of visual tour of how to set up your VCN. And I will go ahead and pass it over to Ernesto to take us through the second half.
So we're going to continue with discussions on VCN security, the load balancing service and connectivity options. So we'll begin with the security list. This is a common set of firewall rules associated with the subnet and applied to instances launched inside of a subnet. So it is depicted here on the diagram as a shield on the subnet itself. So you can see both of these subnets have their security lists attached. And every single rule you have on a security list is applicable to every node in the subnet it is attached to. So if you don't have a permission in the security list, it will not be allowed because everything is denied by default. And when you create a security rule, you have the option of making the rule either stateful or stateless. So by default, security rules are going to be stateful. And stateful rules basically allow in and out. You don't have to specify an inbound and an outbound rule. You only have to specify one direction. Now, a stateless rule is the opposite. With the stateless rule, you have to specify both ingress and egress rules. And one really important thing to note about stateless rules in OCI is that they do take precedence over stateful rules. Now, in contrast, we have something called a network security group. We often abbreviate this as NSGs. And these network security groups are a set of rules applied at the VNIC level, at the virtual network interface card level, and apply to only a set of VNICs of your choice in a single VCN. So, for example, if you have VNICs that belong to a set of compute instances that all have the same security posture, you would simply add the VNIC of interest or the VNICs, plural of interest, to the network security group, and any VNICs added to that group are going to be subject to that group's security rules under a network security group. So in summary, security list applies to all VNICs in a network or all VNICs in a subnet. So if I had multiple VNICs within the subnet, they would, and a security list attached, all of those VNICs would have to abide by the security list. Now, an NSG is applied to chosen VNICs in the same VCN, and it allows you to be a bit more granular than a security list. So that's the difference between the two. The load balancing service provides automatic traffic distribution from one entry point to multiple servers reachable from your VCN. So it sits between the client and the backends, and it does and it does this through three main pieces. The first is service discovery. So the load balancer will look at the backend set and see what's available. Secondly, it's going to perform health checks to ensure that it is directing traffic only to healthy backends that are available. And then the third piece is algorithms on how it distributes the traffic. And this is something that the user decides during configuration of the load balancer. And you have three options. There's round robin, and this is the default policy. So it's going to distribute incoming traffic sequentially to each server in a backend set list. You also have least connections, and this is going to route the traffic to the backend server with the fewest active connections. And the last one is IP hash, which uses an incoming request source IP address as a hashing key to route traffic to the same backend server. Now, some of the benefits of using a load balancer are listed here. So it is fault tolerant and highly available. So by using the health checks and the algorithm that you set, you will or it will route around a bad or overloaded backend to really avoid overwhelming a single server. And if one availability domain has an issue, you can still be up and running in other availability domains. For scale, because you are using an algorithm to balance your traffic evenly, right? So you are going to be able to scale usage of your pool evenly, ultimately maximizing throughput. And another advantage is naming resolution. So name resolution can be delegated at the load balancer level, and the backends don't need public IP addresses. So this means the load balancer can balance traffic coming from the public internet into your cloud environment, or you can actually park the load balancer in your VCN, and it would route traffic internally. So in this diagram, I'm going to show how a load balancer works. So by default, the load balancer comes in pairs. There's an active and a passive, or in this diagram, it's labeled a failover. So if the load balancer is provisioned in a multi-availability domain, the the active and the failover load balancer will automatically reside in a separate availability domain from your active load balancer, providing that high availability and really avoiding that single point of failure. So if you are in a single availability domain region, which in the US is only San Jose at the moment, it will actually be distributed across fault domains. But for the most part, all of our regions have three availability domains, again, with the exception of San Jose, and these two will be in separate ADs for that high availability. So in this subnet, we have our public IP address with our active load balancer, and then the failover load balancer pair. And then below that, we have another subnet housing our backend set with four backend servers distributed among both of these ADs. So quickly going through the flow of traffic of this diagram, a connection is going to come in. It's going to get to the listener. It will see that both of the ADs are up and send traffic to the active load balancer. And based on the algorithm you choose for the load balancer is going to distribute that traffic. So for example, if you chose round robin, it's going to send traffic to the first backend server, then the second, then the third, et cetera, and follow that path or that algorithm. Um, if you select least connections as your algorithm. Let's say server one, three, and four have two connections, but server two only has one. Then it's going to send the traffic to server two and continue that approach. Now, if a disaster were to happen and availability domain one goes down, but you continue receiving connections like you do, business as usual, the listener is actually going to realize that AD1 has gone down, the active load balancer, and that AD is no longer going to be active, and a failover to that passive load balancer will occur and is going to start sending the traffic to the load balancer in 82, which was once that failover load balancer. It's now active. And due to the health checks that the load balancers are running continuously, it's actually going to notice that the backend servers in AD1 have gone down as well with AD1. So the active um, so then it's actually going to start just sending traffic to the servers in 82 using your chosen algorithm. And once 81 is back up and running and the load balancer acknowledges the backend servers in 81, um, and it shows that it can take those requests again, due to the health checks it conducts, it will add those backend servers back into rotation. Moving from load balancers to DNS service, which stands for domain name system. This service helps you create and manage your DNS zones. So it's going to translate human readable domain names like oracle.com to machine readable IP addresses so that your operating system can connect to it. So if you type oracle.com into your browser, the operating system on the computer will ask a resolver that queries several different DNS name servers, and this is where your DNS records are stored if they know the IP address for oracle.com until it finds the authoritative name server for that domain. Once it does, it'll respond with the correct IP address, and then it's going to return it to the browser and take you to the right web page for our oracle.com landing public page. And some benefits include it being a highly available internet-facing DNS, You can secure internal DNS for OCI workloads, basically saying you can deploy private DNS for internal workloads. And your requests are also directed based on load, location, and source through steering policies to serve intelligent responses to queries and really distribute traffic according to logic that you define. And with DNS zone management, you will be able to create and manage zones and records, import and upload zone files, filter and sort views of zones and records. There's a secondary DNS support, and it will have a fully supported API library and software development kits. With traffic management steering policies, these really help you guide traffic to endpoints based on various conditions, including uh, endpoint health and geographic origins of DNS requests. And here's a list of some of the policy types, starting with load balancers. So we have two main ways of splitting, either round robin or it can be assigned equal weights to distribute traffic evenly among endpoints or custom weighted via ratio assignments. We also have failover. So these policies let you prioritize the order in which you want answers served in a policy. So, for example, primary and secondary, the health checks monitor the primary endpoint and if the primary isn't healthy, the DNS traffic will automatically steer to the secondary, also referred to that failover, right? We have geolocation steering. This is pretty straightforward. It's going to distribute that traffic to different endpoints based on the location of the end user. And these geographic regions can be defined as continents, countries, or states, or provinces if in North America. ANS or ASN steering, I'm sorry, steers traffic based on autonomous system numbers. And IP prefix steering steers traffic based on IP prefix of the originating query. For connectivity options, we have three main forms of connectivity. So the first one is the public internet. You will have access to reserve IPs, ephemeral IPs, and internet data out pricing. So in most cloud providers, you have egress costs. Well, in OCI, we have something called internet data out, which means that you only pay when data leaves the cloud region, where the first 10 terabytes are free per month. And then I believe it's metered per gigabyte after that. We also have VPN Connect. So this is going to be IPsec authentication and encryption. And these are the two main options here. OCI Managed VPN, which is free, or you can have a software VPN, which is going to be running on OCI Compute. And the VPN service itself is free, but there is going to be metering on the compute it's running on using that same internet data out pricing model that I just touched on. And then lastly, we have Fast Connect, which is our high-speed, low-latency connection that allows you to access public and private Oracle Cloud services from your local infrastructure. The connection is enabled via dedicated lines, so it's going to bypass the public internet to really help reduce that network unpredictability and congestion, giving you a consistent network experience, kind of like your own HOV lane. And the port speeds available are 1, 10, 100, and 400 gigabits per second. And since this is a monthly subscription, you will have unlimited egress and internet data out pricing because they're already included in its entirety. Um, so these are our three connectivity options. Um, if you have a co-location, if you are already in a data center, it is being deployed. If you don't have a data center in the same edge, you can work with our Oracle partner that already has co-locations with Oracle. And if you don't have a network service provider, then we can work on co-locating to OCI's edge on your behalf as well. That would be a longer process, but we do have our partners like Equinix that we have that co-location enablement, and it's quite a more seamless process than going with MSP that we don't have a co-location with yet, but it can be done. And this is the Fast Connect example, or a Fast Connect example. Here we show both private and public connections. Public in blue, private in red. The Fast Connection, or the Fast Connect public connection, here is going to route um, us to the public VCN routes accessible from the public internet, or OCI public services, like object store is shown here, but this can also be Oracle functions or Oracle streaming services. For the private peering, this is going to advertise private and specific VCN route. So in this case, it's going to our DRG gateway. So it's likely going to give you access to the VCN itself or the subnet. It really kind of depends on what your security rules and your security lists look like, or your NSG rules look like. Um, but having said all that, I'm actually going to jump into the console really quick and do a demo on Network Visualizer, and I have that already pulled up here. And basically, the Network Visualizer, if I duplicate this tab, that way we don't have to wait for it to load. Um, when you go to your homepage in OCI, it can be found under this navigation menu under networking and under the network command center. There's network visualizer, or you can simply search it up in the search engine box under services, network visualizer here. So either way, if you're not wanting to search for it through all these steps, you could directly do it through the console itself or the search engine itself. But it is a troubleshooting tool that you could use to kind of see the topology of your network, and see where those connections are located. And I'll quickly go through um, that here. So with in this diagram, it's basically going to there's three different map modes, or topologies is what we call them. There's the networking topology, there's the VCN topology, and the subnet topology. And I'll go through all three of them with you guys so you know where they're located and how to use them. It's a bit confusing at first, but I hope to clarify some of these things in this demonstration so you know how to navigate it well. We're first going to look at the regional network topology map at a compartment level. I would choose a root compartment, but since the root has a ton of resources deployed with different compartments, it usually it takes more time for it to load, and there are display limitations. I believe you could only see 25 VCNs per compartment at a time. There might be a service limit increase if you reach out to Oracle support to increase that for you, but by default, there is a 25 VCN limit. So I'm currently looking specifically at my compartment. So under the root compartment, we have our own sandboxes for our team, and this is my compartment we're currently looking at. Here, you're going to see a high-level layout and routing topology of all the VCNs within this compartment and scope, and the region. So the region also matters. I'm in Ashburn. We won't see resources in Phoenix, for example. And here you could see a couple different VCNs. And so in the Network Command Center, if you hit Learn More about Network Visualizer, it gives you some of the display limits here. I mentioned 25 for the VCN, but also if you scroll down, there's a legend of what each one of these shapes mean. So I won't go through this, but I will go through it as in my demonstration. So um, these figures here will be considered VCNs. What's attached to them are gateways. So this one's an internet gateway. This is a local peering gateway. This is a NAT gateway and a service gateway. And then this is what we see here, this big sun-looking thing. It's called a DRG. So this is our dynamic routing gateway. You can see some of our VCNs are attached to this DRG. Um, and you can also, if you choose to, see you could see the nested compartments if you want. I have for this compartment, I have one child compartment for mine. It's called RPC compartment. And if I wanted to see those resources in this diagram, I would just hit click include child compartments. I won't select it now because it does take some time sometimes, and I don't want to delay the demonstration, but that option is there for you. So again, this is the network topology view of the map. Now we also have the VCN topology map. So you would click to see the VCN topology, you would basically just click on any of the VCNs of interest. I'll select the VCN one. And in the resource summary on the right-hand side, when you select one, you have details of the VCN itself, like its OSID. You could see it directly here. This is the Oracle Cloud Identifier. Every resource in your tenancy is going to have its own unique OSID. It's going to have the name and an actual link to the resource itself. So if I wanted to see more details of the resource, I could click on it and it will take me to the VCN itself here without me having to go looking for it. Um, the compartment it's in, so you could see the exact path. So the root, sandbox, my compartment that we're currently looking at, the state, so it's currently available, the IPv4 scatter block range, the default route table, and again, a link to that route table itself, the DNS domain name, and when it was created. Below all of this, we have a resource map section, and we have two options here, view VCN resource map and view VCN security map. I'll first click on the resource map and then I'll go into the security map itself. So again, selecting the VCN, I selected the VCN one to start with. And as this loads, here we will see the subnet in the VCN that I selected with the corresponding routes or routes to the gateways it's attached to. So this subnet within the VCN within this VCN is attached to a internet gateway and a local peering gateway, and you can see this local peering is attached to another VCN. So that's a local peering connection that we're seeing at the moment. In this case, we only have one subnet, again, subnet A. But if I click on the subnet, it's actually going to highlight, it's going to be highlighted and it's going to display the route rules for that connection, as well as a resource summary on the right-hand side, similar to what we saw when we clicked on the VCN earlier. Now, if I click on the route itself, it will display the routing summary as well as a link to the route table the subnet has attached. So basically, the first route target is this local peering gateway. So if I click on that, you see the routing summary. The destination is subnet A. Destination 2 is the internet gateway. IG1 is what this internet gateway is called. IG1 you can see here, and has a destination of quad zeros, basically indicating it's open to the internet, and that's what we're using the internet gateway for, correct? And then the second one is so I have to click on the subnet, and then I can click on the role routing summary here. The destination to subnet A, destinations to LPG1. It's what this local peering gateway is. And then you can see here the destination CIDR, and that destination CIDR is actually the CIDR block range of VCN2, which is where that connection is being routed to. So while viewing any of these map modes, um, you could select or you could easily switch map mode on the top right corner. So we started with the routing, and then I said I would go to security. I could easily toggle between the two. So now I'm looking at the security view of the VCN topology, and the security map will display your network security lists and network security groups attached to your subnets. So Subnet A, there's only one subnet in this VCN again. You could see it only has one security list attached to it. We don't have any network security groups attached to the subnet or anything inside of the subnet, any VNICs. So nothing's being displayed there. But when I select the security list, I'll get a resource summary again. Um, and and if I had an NSG, I could do the same thing for that as well. And then lastly, so that's the security. Lastly, there's a subnet topology mode, and you would need to be either in the routing or security map mode of the VCN in order to click on a subnet resource on the map. And once you have a subnet selected, I'll select here subnet A. Below you have two options on the right-hand side. You're able to view the subnet inventory map. And this inventory map will display any instances you have in the subnet, load balancers, if you have a file storage service in this subnet, and also OKE clusters housed within the subnet. If I click on it, I don't currently have anything in this subnet because we're in the process of cleaning up our tenancy. But if we had any instances, any load balancers or anything like that, that would be shown here. And then, like the other two map modes, we can toggle between the two. So that's the inventory, and then we also have the security map mode on the top right corner. So here you would see um, the security list for your instances within the subnet in scope. So I had an instance, and that instance, that VNIC of that instance was part of an NSG. You would see that here, and same for the security list. And all the security, everything within this subnet would be attached to the security list because the security list would basically um, be the security rules for the entire subnet itself. But you can use these in conjunction to one another. Um, so that is the the network commands, the network visualizer demonstration I wanted to demonstrate. If I go back to the map mode and let's see if I can actually include child compartments, if that would load right away, you could see how that would look separated from my resources in um, the parent compartment here. Yep. So we were seeing this one previously, but now I included the child compartments, and these moved around. You can move these as much as you want. So if they're overlapping, if you want to make it more like that, you can. But this is what was in my child compartment, and you can see in this one. This one is actually in Ashburn. IAD is Ashburn. VCN1 is what I called it. It has a connection to a dynamic routing gateway. And then it also has a remote peering connection. So I actually connected this VCN in Ashburn to talk to another VCN in Phoenix. So you can see the route here, remote peering connection, and it's routed to something in Phoenix. Again, I can't see what's in Phoenix because we are in Ashburn map view. But if I wanted to see what it was attached to, I could go to Phoenix itself and see the other side of that connection. And here, if I zoom out, you see PHX, that's my Phoenix VCN2. It's connected to this DRG. It has a remote peer connection, and that connection is connected to something in US East Ashburn, which is what we were currently seeing. So good topology view to kind of see your connections visually to make sure you're doing exactly what you want, or it's also really good for troubleshooting purposes. But the documentation is there on the overview page where you can learn a bit more about it, learn about the legend itself and the limitations. But you can request a service a limit increase if needed based on your justification. That concludes my demonstration. I'll jump back into the PowerPoint to have Borna have some closing remarks.
Thank you, Ernesto. Awesome session. I really appreciate your time and help with the session. Hope it was a great learning experience for everyone. Now, here we have a slide that helps us outline the various learning resources, labs, and certifications from Oracle University, as well as our YouTube channel. If you enjoyed the session and would like for us to conduct personalized training sessions for your organization, please do email us at our personal training email, which we'll find on the next slide. If you can go to the next slide, Ernesto. So, like I said, if you enjoyed this session, then please feel free to contact us and we can conduct personalized training sessions for your organization. If you want us to conduct just a hands-on lab or hands-on lab, we have our live lab program for a more expedited hands-on learning experience for specific cloud topics. And also under our developer experience program, we co-developed a solution based on your own use case. So remember that personal training is an investment we make in our customers to help them grow and develop their OCI skills, and this comes at no additional cost to them. Right. So here we have a calendar that shows all our various offerings throughout the month. If you're interested in joining these other sessions, please feel free to pay a visit to our Day One and Beyond homepage and register. And our next session for February 3rd will be going over OCI integration as well. So feel free to join that session and register for that date. And we look forward to seeing you then. That being said, thank you for joining today and hope you have a wonderful day. Thank you.